Let me start the session for the day. As part of the series of deployment of machine learning models, we did cover a few concepts. And today we are going to talk about how do we use Google Cloud Platform. And we are going to try and understand how we can scale up or scale down automatically using the Kubernetes service, which is readily available in Google. We are going to use GKE, that is Google Kubernetes Engine. It's a service which is a combination of the open source Kubernetes service and on the Google platform. So it's a self-managed Kubernetes engine, which automatically looks at the entire machine learning model requirements. It pulls up all the required resources. It ensures that high availability and scalability are maintained. It also has storage capacity, right? So a bunch of benefits that the GKE service is going to offer. So we are going to take the advantage, leverage on this service, and we will implement a machine learning model with UI on the resources of Google platform, thanks to GKE. Now, let me just do a quick revision or roundabout on all the concepts that we have discussed till now as part of the series. So if you remember the very beginning of the series, we started understanding how the deployment needs to be done for a machine learning model. So we are talking about an ML model. For ease of understanding, we are sticking to a single model for the entire discussion of various tools and techniques that we have in this series. And the first video of this series, we were discussing about the machine learning model, which is multiple linear regression that we used in predicting the fuel efficiency. And we tried to do the local deployment. Even before we talk about deployment, we need to try and define the pipelines. And these pipelines can be of two broad segments. One is the data pre-processing pipelines. So I will say data pre-processing. And then the other one is the machine learning model, which uses hyperparameter tuning optimization techniques embedded in it. Predominantly AutoML techniques would be used, but for our discussion, we have used a single model, which is multiple linear regression. So once these pipelines are defined, the flow is saved in these models. We will take those saved models, right? We save the models and we take those saved models and we try to embed that, integrate with some kind of a web UI. So that as an end user, we will have an interface like HTML page, which can allow non-programmers, customers to utilize the functionality of the machine learning model that we are trying to develop. So two major things. One is your ML code, which is given in saved models, that is your trained and evaluated best model is saved. And we can save it using joblib or pickle libraries. The trained algorithm gets saved. Plus, along with this, we will have to try and write some code which basically allows us to have a UI. Now, we are not software engineers, right? So we are basically data scientists. So we need to try and have our code developed in such a way that it is easy for us to understand in the same lines of machine learning code, Python, right? So we will try and use Python programming language itself to develop this UI. And in order to do that, we discussed that there are three different types of web frameworks which can be utilized. The first one is Flask, and this is my personal favorite, which is a micro web framework library. And we also have FastAPI. This is also a very small web framework, and this is the latest one, and it is fast catching up. It is considered to be super fast. And then the full stack web framework. These are the popular three, right? And I always talk about these three, and in the data science community, we generally use these three platforms for getting us a HTML-based UI, user interface, a web page. The beauty of these libraries is that they automatically render the HTML code that is written to give us the UI. And these HTML codes, you don't have to really write it from scratch. A lot of readily available templates can be used. And thanks to the open source nature of our entire data science community, a lot of readily available code for all the algorithms are there. You just take it up, make the subtle changes which you want to bring in your UI, especially with respect to the data fields that you want to ask as an input, etc. The look and feel, the colors, the image, background images. So those are some of the background changes that you might want to do here. And then embed the saved models in this particular HTML code, a Flask code, you should say. So it is going to try and embed this and this together and give us the UI. This is the first concept that we discussed with respect to the deployment logic. And then we try to use our local machine to implement this particular entire ML code. Post that, we talked about Heroku, which is a cloud-based PaaS service, cloud service. It's basically a platform where it gives you the instances where you can try and put your code, the Flask code, along with your machine learning code, so that you will be able to access that particular functionality anywhere from the world, right? So it is publicly accessible service. And in the interim, we also talked about how important Git repositories are, the code repositories. And we discussed about GitHub, which is the most popular one, but we can also use the other Git buckets. We can have various different repository hubs that we can try and pick up. This is very, very popular in the world. So all this code that we are developing will sit here so that we can have continuous development of the code by different people in different modules that we are trying to develop in machine learning model. So you don't need to do the offline development and then push it. You can have that repository where multiple users can contribute, and you'll always have the latest of the code available for your usage, software development usage, operations usage. So this is the code repository. We've also discussed about this. Then you need to remember that from December 1st, 2022, Heroku has stopped free service. No free service anymore. So if you are fond of Heroku, a lot of people are fond of Heroku. I'm one of them. It's a very, very interesting platform and very useful platform for a lot of newbies, especially the data science community. But unfortunately, they have stopped the free services. Here, we will be using any of these frameworks and then pushing the code into the server. Right? This is something that we have done. Then we have also talked about Streamlit. Streamlit is again a platform which also has HTML embedding within it. So you don't have to write HTML templates separately. You don't need to have HTML code separately written. We can just write our Streamlit code, which tries to embed the saved models within that particular readily available various functions in Streamlit. And thanks to this readily available widgets, Streamlit is going to develop the HTML pages on itself, and then it also going to place the application on the freely available cloud platform within Streamlit public access. So this is also something that we have done. Post that, right? These are all open source tools. Post that, we talked about how do you deploy a machine learning model on cloud platforms, right? And when we talk about cloud platforms, the most popular one being AWS. Here, we used a specific service called Beanstalk, which is used for deploying your machine learning models. Then in the previous session, we used Azure services, Microsoft Azure services. And here we used Azure Kubernetes Service. We call it as AKS. On the same lines of AKS, we are going to try and use Google Kubernetes Engine. Now, the advantages of these Beanstalk or Kubernetes engines that we're talking about are that they ensure that your application is always available. So we will have high availability. Then we have scalability, right? We'll have automatic monitoring, right? Version tracking. We will be able to capture the drift in the models and in the data, of course. And we also have an advantage with respect to single storage point of right location. All these are self-managed, right? That is another advantage, self-managed. And in order to ensure that these services are available, the application that we are developing, ML plus Flask application, for example, is going to be containerized. So we are creating an image of this code, static image kind of a code. We write, we Dockerize this. That means we containerize this using the software called Docker. And this image is made publicly available or is basically available to the respective end users who want to consume it, either publicly made available or using some private credentials. We try to restrict it. Restricted access is given to the images. And these images that we create here, the image is getting deployed. Right? When I say deployed, basically is containerizing the image. So it becomes a runtime instance, right? So this image is getting generated as a runtime instance. And this is done using a Kubernetes engine. To start with, Kubernetes engine is an open source software which was developed by Google. Okay, and what does that do is when you have a lot of containers, right? I mean, you can have multiple containers, for example, and these containers can be managed automatically using the Kubernetes engine. So here we will talk about pods. Pods are nothing but your instances, for example, runtime instances. So you can have multiple pods which can allow us to access the application. As an end user, you'll not feel what is the difference. These are self-managed, right? So kubectl is the function in Kubernetes, which allows us to manage all these pods. These are like multiple individual independent services which run instances, which run the same service. So if by mistake any pod is cancelled or has some issue, then Kubernetes is going to ensure that we have another pod made available. So you get the service as an end user, right? You don't need to really worry about any issue. So these are basically done in the nodes, right? It has storage, it can be scheduled, and it can also control all the resources that we have. And these Kubernetes engine is having load balancer, it contains storage options, it contains various cloud operations capabilities, and it also has restrictions, implementations, security implementations, basically using VPC networking as well. Right, so all these are the various services that are self-managed thanks to the GK engine. So we will get our raw data. It could be from database. It could be any services. If I talk about GCP service, it could be a BigQuery, for example, very popular data warehousing platform in GCP. Your data is here. We establish a pipeline, and then we will try to use that particular data for machine learning model development. Data pre-processing happens, transforming happens, scaling happens, training on training data set, then doing hyper tuning using validation data set. Finally, you choose the best model using test data. We use hyperparameter tuning optimizations, etc., etc. And once the best model is defined, we save those best models and then we embed that using Flask code. Okay, this is basically what we have. Then what we do is we use the Docker software to create an image of all this particular code. Now, once this image is created in the Docker, it can reside in the image can reside in your local instance, but we can also try and push it on Hub, Docker Hub, which is global, right? Global repository for all the images. We can try and push this image onto the Hub. From Hub, using GCP services, we will try and register the image into the container registry. So GCP provides the container registry where we can try and register this image that we have just pushed into the public platform. And all that image goes into your registry. It registers that. And it creates a image on GCP container registry. Or you can say it is GCP Hub. This is an open source hub, and you'll basically try and connect here to take the image and place it in the GCP platform hub, right? From that container registry, once you have the image, you try to generate a service. So we will have to create a cluster, Kubernetes cluster. It can be self-managed, or you can have a basic cluster. And once we have cluster with multiple nodes, cluster means you will have not one service, not one computer, but you'll have multiple computers like this. Depending on the demand for the service, depending on the volume of the application that we are dealing with, depending on the load that the application is going to take from the customer, when customers request, the number of requests that are going to hit the particular service, you're going to define the number of nodes for your cluster. Right? Each node is like a separate instance computer. All right. And once the cluster is ready, the GKE is basically allowing us to create the images on these multiple nodes. So everything is automatically taken care. You don't have to worry about instantiating that image into a container, runtime instance, and then provide that application. Everything is automatically taken care. And as an end user, you'll only see the UI. And you will be able to access the functionality of your machine learning model. Right? So this is basically what we are going to do now. So let me take you to the hands-on. Right? We'll directly jump into the hands-on. Now, in order to work on this particular deployment, we need a GCP account to start with. I have that. Then we need to have a machine learning model. We need to have a Flask application, which embeds this particular code. You can say these two are together. Then we need to have Docker installed in our local machine. All you need is Docker software, which is again open source. Just install it. And once these are done, we can try and create image, push that image into the GKE, Google Cloud Platform. You register it and then use the cluster, Kubernetes cluster, to deploy that image so that the end user can access it.